Hi, welcome everyone to another Tech Talk. Tonight we've got Gregory Levine-Rozenvayn and Nathan Richardson here to speak about the JAMstack and serverless functions. So before they begin, why don't we all unmute ourselves and give them a big round of applause.
Very good, Nathan. Very good, Nathan. Yeah.
Jamming.
Thanks for the intro, Shaw, and thanks to everyone for coming to our Tech Talk. I'm Nathan.
And I'm Greg.
And we'd like to start off by thanking SingleSprout and Codesmith for sponsoring this Tech Talk. So today we're going to give you an introduction to the JAMstack. So we're going to talk about what it is, why it's relevant for you to know about, and also how serverless functions have really made the JAMstack able to be fully featured dynamic applications. So first of all, let's talk about where JAMstack gets its name. So it's important to note here that there's a difference between the JAMstack and a traditional tech stack. So you might be thinking of something like that you've used a MERN stack before with your Mongo and your Express node setup and React. But with the JAMstack, we're really talking about more of an architecture for your website. So you could be using any of those front-end frameworks for your JavaScript. And you'll be interacting with APIs as your source of data. So we're going to go into what each individual piece of this means. So when we talk about JavaScript with the JAMstack, most of you know that with modern web development, we use JavaScript on our front end and our back end now. So we'll be using Node.js on the back end with maybe a React front end or a Vue front end. With JAMstack, though, when we refer to the JavaScript portion of this, we're specifically referring to JavaScript in the browser. Our APIs are really what we're talking about when we think of how backends would usually get data for you. It's going to be working much the same way, except we're going to be getting data from our front end, utilizing what are called serverless functions, which Greg is going to go into more detail on later. But for now, just know that the APIs are the data source for our application. And as you can see this with this graphic, we can have multiple different data sources in our app. In fact, this is a key part of the JAMstack. It's known as decoupling. It's very common and best practice for JAMstack applications to utilize multiple APIs to handle different systems. So what decoupling basically is it's the separation, it's creating that separation between your systems and services. So by separating each service you needed to operate your site, you basically can swap in and out different services when they need to be upgraded. You can have these services be handled by specialists within the organization or through third parties. And what this means is you'll have optimal performance of every piece in your application. Because we have such a thriving API market, this has allowed engineers to utilize these complex APIs without having to take on the risk and burden of having to host these services themselves. So the final part of our JAM acronym here, the markup, this is just the plain text formatting that's going to be converted into HTML. So for this, you can think about just the content that's on the page. When you have text, images, etc., we're using that markup to create content and then convert it into HTML. This markup content will be saved on CDNs, which allows us to have faster load times. And we're going to go into more about the CDN portion of this in a bit. But just to review the overall architecture here, when you have a traditional app, you might have the client making requests to your web server, which could be, for example, like a CDN on AWS. And that will then make a request to the app server. This app server will be talking to both your database and your application, or through whatever content management service you're using. And you will then make changes to both the application and your database. With the JAMstack, we have nothing moving past the CDN. So your client makes a request, and you will retrieve the statically generated content directly from the CDN without having to make further requests to the app server. So let's talk a little bit more about what these CDNs are. We've talked about how our markup is being saved on CDNs. So let's talk about what that means. A CDN is just a network of servers that's placed as close as possible to the client. So when sites can be served entirely from a CDN, all of the pages are already available and as close as possible to the user and ready to serve. This is what allows for a high performance without expensive or complex infrastructure. The JAMstack utilizes CDNs with what's called pre-rendering. So pre-rendering just means that our entire front end is pre-built into these optimized static pages on our CDNs. We generate our markup, which is representing that view in advance of when it's required. And this happens during a build rather than on demand, such as when you would have, for example, server-side rendering, so that the web servers don't have to perform this activity every time a request is received. These pre-rendered assets live on the CDNs as close as possible to the client, and that's what gives us our super fast loading times. But what makes this dynamic fetching possible is the rise of Lambda functions or serverless functions. And Greg is going to go more in depth on that right now.
So the first question that most people ask is, how can I run my app without a server? But really, serverless does not mean no server. But before we go into that, let's talk about how we traditionally think about servers before this serverless craze came about. Traditionally, one has to buy or rent physical servers that live in data centers, which means someone like John here has to manage them. Scaling your servers is difficult to manage because it's not always clear when traffic to your application will spike. Over-provisioning is when you have more servers than traffic. And although your application will run fast for your users, you will ultimately just be burning your money. Under-provisioning is when you don't have enough servers to handle the traffic to your site. This will cause sluggish speeds or worse, crash your application. If you're buying or renting your servers, you'll also be on the hook for the server maintenance. That includes fixing hardware, keeping up to date with security upgrades, and upgrading your servers at the end of their lifespan, which can be only 3 to 5 years. With serverless, you leave the responsibility of managing and housing the servers to someone else, and you only pay for what you use. Behind the scenes, your serverless provider will scale for you and allocate servers for you depending on the traffic. No buying physical servers, no load balancing. So what does this actually mean to you as a developer? It's that you don't have to worry about the servers where your code is running. Also, you don't have to worry about the maintenance of hardware, configuration of network, installing software. The scaling and everything else are abstracted away by the serverless provider. But how do we connect to the serverless platform? With serverless functions, otherwise known as AWS Lambda functions. Here is a serverless function through Netlify. As you can see, the syntax is very similar to how one makes an API call from a Node Express environment. At the bottom of this function, you see an if statement that's checking for the get method. It then invokes the get users function, which in turn invokes the axios.get, which is just a simple fetch call, and then parses the data and so on. From a development perspective, a serverless function is a bundle of code that you can upload to a serverless provider, such as AWS or Google. This code can be configured to respond to a request via a URL like this one, or can run on a schedule, be called by other services, or other serverless functions. And then in conjunction with other cloud services like cloud storage, database systems, authentication, it's possible to build large, robust, and scalable applications without having to provision a single server yourself. So that's a lot of praise for serverless functions, but they're not perfect for every application. The downsides to serverless function are the actual model that they hinge on. Because you only pay for what you use, the serverless model is designed to be a short-lived process. Each function can only run for a short time. For example, 15 minutes max on AWS, 9 on Google, and that's not a good solution for long-running jobs like processing large batches of data. Also, since the servers are scaled for you and you only pay for what you use, it's hard to predict how much you will actually pay for your serverless usage. So then budgeting becomes a variable. Another problem you can have is something called vendor lock-in. Since each server provider has their own cloud infrastructure that might not speak to other cloud infrastructures, you can get stuck with a particular provider for all your needs, making you inflexible and making it really difficult to switch if you ever had to. Finally, you can experience something called cold start time. This is the time it takes for your serverless provider to initialize your serverless functions, which can take up to a second to happen. Once your function is initialized, the provider will keep it alive inside of a container for you. But if that function isn't called again and your container is idle, it will then be discarded and you'll have to deal with the cold start time all over again. There are some workarounds like a warm-up plugin that pings your serverless function at a set interval to keep that container alive, but that's not a perfect solution. So is serverless really going to replace the traditional backend? It's hard to say. There are still plenty of applications that need the flexibility of having a dedicated server or servers running 24/7. However, the rise of serverless functions have allowed the idea of the JAMstack to thrive, and new functions and frameworks are being created all the time. So we'll just have to see what happens. Here's some sources if you want to look deeper into serverless functions. Thank you so much for coming to our tech talk. And please come to us with any of your serverless needs.
All right, before we take some questions from the audience, why don't we all unmute and give them another big round of applause.
Good job, guys.
Awesome. Brian, you have a question?
Yeah, I appreciate you taking the question. I was kind of curious, what's like a good use case for a serverless function?
Oh, I think I can take this one, Nathan. So that's a great question. Let's think about a site you might be making that's it's completely static, except for just one feature. Let's say it's like a mailer form that you want the user to fill out and then like send you back some kind of data. You can utilize a serverless function to take in that data and pass it off to your serverless database. Otherwise, you would have to build a whole backend to take in that data, pass it to your DB, and then re-render the page. That way, now your page is still completely static, but you have the flexibility to be dynamic and deal with data.
Awesome. Thank you so much.
Yeah, thanks, Brian.
Great. David, sounds looks like you have a question as well.
Yeah, I was just wondering, can you guys go into a little bit more detail about the differences between CDNs and web servers? I'm just curious about that.
Yeah, I can take that one, Greg.
Thank you.
Great question. So with a traditional server, you would have, like, let's say you had a server in Dallas and you could have users in New York, you could have users in Australia, wherever. The user experience for someone across the world is going to be totally different. It's going to take longer for them to get the data back than for someone close to that server, say someone in Austin. So with a CDN, you have this data that is dispersed across what are called points of presence. And these are typically placed throughout the world in high traffic areas. So that data is very close to the user. Now the CDNs won't do any server-side rendering, so they'll just hold static assets. So if you need to do any of that, you'll need to utilize your web server. But that's why the rise of these Lambda functions, these serverless functions, have changed everything, because now you don't need to utilize the web server to do that rendering.
Thank you very much. It was very informative.
Awesome. I don't see any more questions in the crowd, but that was super informative. Thank you so much, Gregory and Nathan. Greg and Nathan. All right, thank you. All right, have a good night, everyone.